Hi folks, today we're going to demonstrate the speed up in model startup time by using pre-cached Triton kernels. So the first thing we're going to look at is we're going to have Kubernetes set up on a single node, and we are going to launch a pod that has an instance of VLLM running in it, and we're going to essentially measure the startup time for that VLLM model that's using Triton Flash attention. And then after we've done that and we've measured those values, we are going to start on a different pod on that worker node. The difference being that this pod is going to run an init container, which is going to leverage Thunderbolt. Thunderbolt is a utility that we use for wrapping Triton kernels in OCI container images or extracting them from OCI container images. So we essentially have all the Triton Flash attention kernels pre-wrapped inside an OCI container image that lives in an image registry. Thunderbolt's going to run, it's going to pull down the cached kernels, and it's going to extract them to a shared volume. And then when the VLLM container starts up this time, it's essentially going to consume those cached kernels from that shared volume, and we're going to see the benefits in terms of model startup time from leveraging those pre-cached kernels. So let's go have a look at that. Okay, so let's start up by setting up our Kubernetes node. I just have a simple script that does this. It sets up kubeadmin on this node in particular, but what's really interesting is that we also use the AMD GPU device plugin to pass GPUs to our pods. So let's just start that up and see that everything runs okay. Okay, that ran. So we just see some of the main pods up and running, and we can see here we have the AMD GPU device plugin, and that should be running at this stage. Yep, perfect. Okay, so what we're going to go ahead and do now is have a look at our VLLM pod that we're going to run that doesn't have any kernel caching. So essentially I've built up a VLLM container image, and we're going to reuse that. We're going to reuse this Quen model as part of that image, and we're going to use it in serve mode. And here's where we allocate the AMD GPU to this pod. So let's go ahead and do that. Let's have a look at the logs. This is the model starting up now. You can see it automatically detects the platform as ROCm. This part takes a short while to run. It's going to use the ROCm flash attention backend. Okay, so essentially I have a script that's monitoring all of these logs and pulls out these stats from the actual logs themselves. So the wait load, we can see the wait load time, the model load time, which is about 20.62 seconds. The memory profiling time takes about 31 seconds. There's a time for CUDA graphing, and then the total startup time here is about 51 seconds. So let's go ahead and tear down this. Okay, so now that's gone. Let's have a look at the pod with caching. Or at least it's YAML. So here we have an init container that runs. This is going to run Thunderbolt. It's going to extract the kernel caches from this container image, and it's going to put them in home vllm.triton.cache, .triton/cache, and that volume is mounted as part of that init container. It's also mounted into the main container itself, and we're going to run the exact same model again, as you can see. So let's go ahead and do that. Let's have a look at the logs. And this was the init container. Make sure that ran. So we can see this is Thunderbolt running, and it's extracted the cache here, and we see the contents or the directories of that cache there. So let's go ahead and follow the logs of the actual main pod itself now. Okay, so here we have the startup times for the cached Triton kernels. So we can see that the overall startup time is significantly shorter. It's about 26 seconds. So I'm going to paste in the previous results just underneath the cached results here, so we can easily see the difference. Okay, so the wait load startup time, it's negligible, the difference. The model load time seems to be halved essentially, and the memory profile time, this is what takes significantly less time, as we can see, and this is where essentially we get major speed up on the model startup for this model. So with the cached kernels, the cached Triton kernels for VLLM flash tension, we see the total startup time here as 26 seconds, and without caching any kernels, the model startup time is nearly 51 seconds.